So in this video, I'm going to do a kinematics example. Kinematics are those questions about velocity and acceleration and displacement. And what we need to know about them is that you use derivatives to go down the chain and anti-derivatives to go up this chain. So this would be a displacement function. Displacement can tell you things about the displacement of the object or the distance of the object. Velocity function can tell us about velocity or speed. And this is the acceleration function. So to go down this chain, we're doing derivatives, which means if you need to go up the chain, like for example, if I gave you an acceleration function and I asked you to give me a velocity function, you would do an antiderivative to get there. So this is kinematics in a nutshell. It's all about calculus, derivatives or antiderivatives. So in the question at hand, we have the speed of an object moving in a rectilinear fashion. So that just means an object moving along a line. It's given by v of t equals 2t minus sine t. So there's our function. It's a velocity function. T represents time after 12 o'clock. The displacement of the object at time 0 is 2. So there's a specific piece of information about displacement, like an ordered pair almost. And we're asked to find an expression for the displacement in terms of t. So we're given a v of t, and we're asked to find displacement, which we typically call s of t for whatever reason. So I'm going to have to do an antiderivative to get there. I'm going up the chain that we had on the board a moment ago. So the antiderivative is this. We're going to do the antiderivative of this function. When we set up an antiderivative, we put a dx at the end, or in this case, a dt, because the variable we're talking about is t. And then we check out our function that we have to integrate. Does it require the u substitution? Because there's no product here, other than the 2 multiplied by t, and 2 is just a constant, so that's easy enough. There's no product, there's no chain rule, there's no quotient. I'm probably not going to need to use u substitution. That makes this a little bit easier. And this means I can integrate term by term. So I can just get the antiderivative of that, and I'm ready to do it. So the antiderivative of 2t means keep the 2. Any coefficient is just going to stay in your integral. And then t, you increase the power by 1 and you put it over the new power. We'll clean that up in a minute. And then minus sine t, we're going to keep the minus sign like a coefficient. And the antiderivative of sine is negative cosine. And then don't forget, when you're doing a general antiderivative or general integral, you're going to put a plus c at the end. So this is our function for s of t, the displacement, right? When we integrate velocity, we get displacement. Now we just have to clean it up and see if we can find our c value. So to clean it up, I have 2 and 2 going to cancel out, give me just t squared here. Minus and minus. It's going to give me plus cosine t plus c. And this is where the other piece of information comes into play. We know this is true of the displacement of the object, that at time 0, the displacement is 2. That means I can plug in 0 for t and set it at that time equal to 2. Change back to blue. So we have at time 0, the displacement equaling 2. So we use that like an xy pair, or in this case, a t s of t pair, and see if we can solve for c. Now, normally when things are 0, they just like disappear, right? 0 squared, it's just 0. I don't care about that. But the cosine of 0, we need to just be a little careful about and think about, because cosine of 0 might not be 0. We've got to think about our unit circle, think about a 0 radian angle that's over here, with the coordinates of 1, 0, and cosine is 1 at that angle. So this ends up being 2 equals 1 plus c, so 1 equals c. So for full credit, our final answer, the expression for displacement is going to be t squared plus cosine t plus 1, which was the c value that we found. And that is it.